Hello everyone, myself Kimbudurji and I'll be presenting on extraction by caving method. Basically, I will be talking on sublevel and block caving, and under it I'll be mentioning its characteristics of the method and some designs and development and production. So firstly, about sublevel caving, it is the one in which the ore is extracted via sublevels which are developed in the ore body at a regular vertical spacing. So sublevel stopping recovers the ore from the open stopes which are separated by SS strips and each connected to a ramp. Here the short blast holes are drilled from SS strips in a ring pattern, and the ore in the stopes is then blasted and collected in the draw points. Blasting will start at the hanging wall. So here in the figure it's clearly shown the hanging wall. So blasting will start from that hanging wall and then mining will proceed towards the footwall. As the mining goes downward, each level is caved into the mine openings with ore materials being recovered while the rock remains behind. So the loading and the will continue until waste dilution is too much high to work. As mining recovers the rock without backfilling, the hanging wall keeps caving and continued mining results into subsidence of the surface, causing sinkholes to appear. And the next slide, I have a picture of subsidence, how it happens. And coming to the characteristics of this sublevel, the fragmentation is done by explosive, which is also known as induced caving, and the ore is detonated with drilling fans ascending. The surface overlying should collapse as the ore is removed. And coming to the development plans on sublevel caving method, these are the designs for with varying depths and thickness of the ore body. This is for steep dip and this is for flat dip. So coming to the development in sublevel caving, the development in sublevel caving requires a significant development. In sublevel caving, it requires significant development. The cost in development is many times higher than the production. So the ore body is divided into panels depending on the scale of the production and reserves per vertical meter. Each panel is divided into sublevels which are spaced about 20 to 30 meter. Here the main point is by increasing the space between the sublevels, the development can be minimized and ultimately it increases the production, because if the development is minimized, the production level is increased here. And the lower level serves as the ore passes. The access to the sublevel is accomplished by a ramp which is between the ends of the ore body. In case of traverse sublevel, the crosscuts traverse the deposit going to the hanging wall, and development is taken at the footwall in case of traverse sublevel. Coming to the production of sublevel caving, it begins at the galleries reaching in contact. The equipments used for the production are drilling, which is ascending, and drill carts with two drills, namely electro-hydraulic and DTHs. Charging is done by pneumatic devices, and the explosive used in common is N4 explosives. LSDs are used for transport and unloading ore. In the end, the explosive consumption is too much high for this type of method, because the dismantling is carried out against the mass of the fragmented rock. So it must be careful in removing we must be careful in removing the ore from the draw points. The removal of material causes little lower recovery, and removal of too much material causes excessive dilution. These are the three main points to be remembered here. There are two major factors which affects the dilution and ore recovery. They are width and extraction of galleries. Width of the galleries and extraction of galleries. The gallery of the production should be as wide as possible here. When sealing the gallery ceiling is concave. The flow of ore is very centralized and inefficient slides, requiring closer galleries. The amount of ore away from the LSDs increases with the increase of height of the gallery production. Therefore, the height should be as low as possible. This is the important point here. The amount of ore away from LSD increases with the increase in the height of the gallery production. Therefore, we should maintain the height of the gallery as low as possible. The advantages of this sub-level caving is that it has high protection rate, and it has efficient fronts and simultaneous mining. It has a possibility of high degree of mechanization, and it's a most safe method for the operators. Disadvantage of this method is that dilution is too much high, maybe too much high, and it has a moderate recoveries, and the consumption of explosives is too much high, and ultimately the cost of development is too much high. So coming to the block caving method, it is generally employed for steeply dipping ores and thick horizontal seams of ore. It is most applicable to large scale or bulk mining, or mining which is done hugely, and it is primarily used in massive steep dipping ore bodies. The block caving method is often done to continue mining after open pit mining becomes uneconomic or impossible. In case of that, block caving method is being carried out. Here is the picture how block caving method is carried out and its operation. It's clearly shown here. And the conditions for the deposit of this block caving methods: the ore resistance should be weak to moderate, preferably soft or friable ore with intense fracturing, and the resistant wall of the rock should be similar to the ore with distinctive interface between or the barren ore, and the driving should be vertical, because the vertical diving is better, but can be flat in some thick deposits. The shape of the deposit large and thick, greater than 30 meters, and the deposit should be uniform and homogeneous because it will suit this method. Depth of the deposit should be moderate, greater than 500 meter and less than 1200 meter. So there are some basic issues of geomechanical to the block caving method: cavability, mine design, fragmentation and extraction control, and its subsidence associated. Cavability. The caving is principally defined by the quality, rock quality, which depends upon the RMR, Q, Q factor, RMR factor, etc., and its hydraulic radius RH. The basic requirement for the method to work is that the ore should fall under its gravity, and the pattern of fracturing the middle for good fracturing at least two families cross sublevel joints between themselves and one horizontal family. Number 2, mine design. It is possible division of area to be mined. Here a division separated by pillars of security blocks sequentially to be mined. Division into blocks without pillars with continuous mining. Selection of extracting ore system. This can be done in 3 ways: by traditional gravity system, or by slusher system, or by using LHT system. Here first of all, traditional gravity system. It is an ideal for very fragmented ores. When the ores are usually fragmented, it is ideal for that. And the loading and transportation system developed under each block. Ore passes are open and finger races with grids. The level of fragmentation is controlled loggers. Finally, enhancement done in the block, which begins at the fragmentation and migration of the ore and rags through the undercut up to the level of transport. This is grizzly system, or the traditional gravity system here. This is how it's being carried out. Number two, by slusher system for medium or little fragmented ores. Development is simplified by omitting grids level. The cones migration ore behind the directly to the points of discharge. The high wear of the pillars discharge requires very resistant concrete coating. Number 3 is by LHD system. It is more of modern system to little fragmented ore. It provides greater productivity draw points, simpler design eliminates the need for ore passes for each draw points, but need area larger tube due to the size of the equipment. Subsidence associated. It is discontinuous and affects large areas of surface. The final geometry of the subsidence area is quite varied: resistance overburden, presence of significant and structural features like dikes, falls and folds, undulating folds, and depth of the mining. It depends upon the depth of the mining and the natural slope of the surface. Here these are the 2 examples of subsidence, how it happens. Subsidence, when the surface roof collapses due to the extraction of ore underneath. So advantages of block caving: here it has higher production rate than any other method in the underground coal mine. It has greater productivity and lower production cost of underground methods. It has the production cost as low, and it has a higher recovery percentage, around 90%, but with significant dilution. And it can be highly mechanized. This is also an advantage of this block caving method, and there's also a good ventilating and security for the workers. The disadvantages of block caving method, the limitations are subsidence and collapse. Subsidence happens in large scale, there's high dilution, and control resumption is critical to the success of the method. The development is very slow, it takes time to develop, and thus for the support, the costly operations are required. The reduction and fragmentation is difficult to predict and control. The method is little flexible and no selective. Possibility of oxidation of the ore due to the long time percolation of water. Thank you and a wonderful day.